Okay guys, this is Matthew with PLC Exchange. I'd like to take a moment here to explain to you our new hashtag add-on instruction for add-on instruction block security. We're really proud of this. What it does is basically allows you to take a customer produced add-on instruction, whatever it be, something you or your company does internally, proprietary. This could be, 1 or 2 or 10 tank controls, some very specific motion applications, anything specific to your industry, specific to your niche that you've spent days, months, years of code behind these blocks here. I don't need to explain to you guys that. Finally, what I've done is built a way for you to protect that. I want to kind of take this time here to kind of showcase how that's done. It's very simple and straightforward, to be honest with you. We've created this add-on instruction called hashtag. That's the name of the product. Hashtag is essentially a surveillance app that takes and reads a bunch of numbers from this hash, and based off these numbers determines if you're running the correct number or not of instances. These instances again are your customer developed instances. This is something that you've developed that you're trying to protect. I'll show you here exactly what's inside this, but this is just something you've designed that you want to protect. So the idea with this software is that you'll purchase this add-on instruction here keyed to your PLC processor here. You can kind of see in the top left hand corner I'm online with a Compact Logix. This is an L24. This works with any of the Compact or Control Logic series processors that have an SD card. We utilize an SD card to key the instructions to a processor and also prevent unauthorized duplication and iterations of your code here. So let me go ahead and kind of explain to you a little bit about this. I'm going to go into a customer defined add-on instruction. So this would be something again that you guys have developed. I'm going to go in here and just kind of take a peek inside. Going to go online with this. So as you can see here, this is something super simple. This is not something worth protecting, but this is just to showcase what's going on in this example. So what we provide here is this hashtag instance block. So this is the one single block that you'll bring into each one of your already created add-on instructions. This here is a very simple instance, and it contains this public hash key. This is what passes back and forth between your add-on instruction and the main add-on instruction here. So going back into here, what we have here is this hashtag instance that takes this heartbeat and makes sure that it's valid, and based on that validity you are going to be able to key any kind of behavior out of this block. So again, this add-on instruction is super simple, but in our case, or in a probably a real use case here, this will be protected with standard Allen-Bradly source protection. So the customers aren't actually going to be able to get inside here, or they just can't make edits. And what that's going to allow you to do is utilize this sync OK bit, and this sync OK bit is what you will lose if there's any kind of tampering detected. So if someone kind of comes in here and tries to duplicate this add-on instruction, tries to create a second add-on instruction, tries to duplicate the hashtag, tries to do any kind of combinations of squirrely behavior to try to essentially get around this protection, this instance created here will in fact detect that, and it will shut down. And what it shuts down specifically is only the sync OK bit. And what that does is it allows you to specifically and custom program into your existing code the behavior that you want to happen when you detect tampering, because Just because you detect tampering, depending on your process, depending on what's going on, you might not always want to just straight shut down an output or a certain process or a piece of process. So this really gives you the customization you need so that you can go into some kind of shutdown routine. Whatever you find is best for your situation, this is what you utilize in your own code, and which enables us to basically not touch any of your IP in this actual add-on instruction you create. You just need to utilize what we're giving you, and then you can do whatever you want with it. So going back out here, I just want to do some quick case studies on what's going to happen here. So just let's just pretend like we want to copy this instruction here. So I'm going to take this guy, just do a real simple copy. Just say this is a machine A, and then the customer doesn't want to spend the money to get you back out here to implement machine B. So he thinks he's going to be smart and just come out here and just make a new machine B. So he just thinks he's smart and says machine B, right? Which they can do right now usually this is how they do it. They can just come in and copy your existing code, and then just have someone smart enough to know how it works to implement it. So let's just do a new machine B here, create that, and then we'll, of course, pin the edits, and then we'll see here. Try to turn it on. Okay, nothing's happening, and it shouldn't. So this hashtag, when it's provided to you, the customer, you give us the processor serial number and the amount of instances you want. That will limit the amount of instances that can run on the processor at any given time. So what this is doing is allowing us to detect a second or third or fourth instance and then act on it. So we loaded this block while it was running. You can see it's not synced up, so the stop bit is on right now. And if we look inside the code here, we're gonna go find out. Let's see here, machine B. So the sync is not okay. That's because it is not handshaking with the main hashtag block. And let's say the customer says, oh, okay, well, let's just stop my machine. We'll go to program mode. Okay, let's restart the machine here, see if we can trick it. And then, okay, now we're detecting that tamper. So here on a full load, we actually go through and scan the whole program and determine that, yes, in fact, you are actually trying to tamper with the hashtag. And then we can detect that, and now no outputs will work. We think this is a pretty cool feature. Really kind of discourages any kind of customers messing around or tampering with the code. It's very picky and precise, and it can very quickly get you into a situation if you don't know what you're doing. So it's a very good way to protect your special IP there in those blocks. So what I'm going to do is delete this block, just show you how easy it is for it to go back into operation. So all you do is delete the unauthorized code, program, back to run. Now your machine's working again. It's just following the code, just like it should. So if everything's working right, no one's messing with the code, again, this really shouldn't do anything at all. You should have no effect on your machine or your process. There's just some information here telling you if the hashtag validate active. So what we do is we do key this to a SD card on your processor, which allows us to detect multiple instances of hashtag. And so what I'm going to do here is I'm actually going to take the SD card out of this processor on my desk, and I'm going to wait about 30 seconds here. And what's going to happen is ultimately it's going to detect that SD card was removed, and it's going to stop the system. So this allows you to prevent a customer from taking the SD card, maybe copying the program, making like an SD card image, and then retrieving that SD card, taking it to a new machine, installing it on a new machine, taking it to a new machine, installing it on a new machine. This prevents them from doing that. Not only is it tied to the SD card, it's also tied to the processor. So here you can see now after about 30 seconds, We've now detected that the SD card has been removed, and now we're no longer allowing the output of the machine. So I'm going to insert the SD card here. It's not going to just fix itself. You have to go to Program, stop the machine, start the machine, and assuming the SD card was reinserted and everything's good to go, everything starts right back up without no further action by you. So that's a pretty neat feature we like to show. It's pretty flexible as far as integration into your code, like we showed here. This is just a brief introduction. One other fun thing that I'm just personally proud about is this hash here. So we've spent a lot of time and energy into generating this random hash. This is the key that is being passed along between each process. It is random, it is unpredictable, and it is what is absolutely encrypting, or not necessarily encrypting, but preventing any kind of unauthorized replication or tampering with your code. There would be absolutely I'd be very impressed to see someone try to replicate this. So anyways, just wanted to show that. Just a little side feature that we're proud of here. So back to the routine. If you guys have any questions, please reach out. Support@plcexchange.net. This is Matthew, and this is #. Thank you.